Hey guys, I noticed that I was watching the previous video that I had posted of doing Euler's method and improved Euler's method that the video just stopped right when I was doing the Excel stuff. So I'm going to re-record that problem again using both methods, both the Euler's method, the normal Euler's method, and then the improved Euler's method. So you'll want to definitely look at this example that I do with you to give you an idea of how to do the problem that I've assigned in class. So let's go ahead and get started with this. And it's going to be the same problem, but we're going to use two different methods, of course, to do it. So the problem that I want us to use Excel to work out is going to be an initial value problem. Your differential equation itself is y prime equals 2xy. The initial value that you're given is y of 1 equals 1. And the step size that I would like for you to use on this project is 1/10. So the step size is going to be 0.1. Now, the question that we want to find here is if we know this information, can we use Euler's method and improved Euler's method to approximate y of 1.5? So that's what I want to figure out. What is y of 1.5? So I want you to do two different Excel programs to approximate what y of 1.5 should be. The first one we're going to do is with the traditional Euler's method. Okay, and the formula for Euler's method is, if you remember, y sub n plus 1 equals y sub n plus h times a sub n. Now on this, you understand this y sub n plus 1, that is what you're using, your Euler's method, you're going to use that to compute y sub n plus 1. That's what you're trying to find. Now the parts of this y sub n, this is your original y. Value. H is, of course, the step size. And the a sub n is the differential equation that you're given in the problem. And our differential equation we're given in the problem is the y prime equal to 2xy. So I'm going to call that my a sub n. So it's pretty easy to key in a problem like this into Excel and use it to compute. So I'm going to try to go slow so you can watch my steps. So let's go ahead and tackle this problem with Microsoft Excel. Okay. And I've got my screen blown up here pretty big so you can kind of see what's going on. So what I'm going to do is kind of make a table here. So I'm going to label my cells. You name cells by a letter and a number. So this cell is cell A1, B1, C1, D1, so forth there. So instead of variables, we're going to use cell names instead of variables. I'm going to call this column my X's. So X sub n column. The B column, I'm going to call it my Y, so Y sub n. I'm going to program in the differential equation A sub n. And I'll go ahead and do one more value here. I'm going to go ahead and multiply the step size. This is H times A sub n. So we're ready to start here. So the first thing we know is our initial value. I gave you that y of 1 is equal to 1. So my first x is 1. My first y is 1 also. So y of 1 equals 1. So the x is a 1 and the y is a 1. Okay? Your differential equation is, the equation was y prime equal to 2xy. So that's 2 times x times y. So to calculate in Excel, you have to put an equal sign first. That means you're going to calculate something. So 2xy, I'll say 2 times the x value. We'll talk about your original first x value. So this is the 1 here that you see in cell A2. So I'm going to put cell A2 down as my x variable. That's the x. So the equation is 2xy, so 2 times x times y. The y I'm going to use is cell B2 here. So B2 represents the y value. And then when I hit enter, it calculates that. So 2 times 1 gives you 2. So pretty easy arithmetic there. And then lastly, it's h times a sub n. So we know the step size that I gave for this problem is 1/10 or 0.1. So we're going to say equal to 0.1 times, well, a sub n is just this value in C2. So we're just going to go ahead and just put C2 down. Hit enter, and it calculates that. Now, if you recall, the step size in Euler's method means how much are you adding to each x? What increment of x are you using? So in our problem, our h was 0.1. So what we're going to do is add 0.1 to your x's each time. The easiest way to do that, we're going to make a calculation here. And we'll come under the in cell A3, we're going to say this is equal to cell A2, the one above it, plus the step size. In this case, our step size was 0.1. So it's just going to add that 0.1 to it. Of course, my next x value would be 1.1. All right. So the next cell, and this is the last one I'm going to actually have to fill in myself. So once we do Euler's method one time with Excel, we're ready to, we can copy and we can do anything we want to. This is the last cell you have to actually program here. Now back in the day, I had to learn programming languages like BASIC or Pascal in order to run a program like this. But Microsoft Excel is wonderful and makes this so much easier and so much better. So I'm going to code right here in cell B3. I'm going to code Euler's method the first time and the last time I have to do it. So we're going to equal. Euler's method says it's y sub n. So y sub n was cell B2 plus h times a sub n. That was the formula. Y sub n plus 1 is equal to y sub n plus h times a sub n. Well, don't we have that h times a sub n right here? 0.2. So that cell is D2. I'm going to add that to it. And hit enter. And it's calculated for me. Now, what I was telling you earlier, I don't have to code anything else because this will copy and paste to cells. All I have to do now is drag the cells. I'm trying to find the approximation of y for x being 1.5. We want to approximate y of 1.5. So I'm going to click on this cell. You see the little white plus sign. I'm going to pull it over to the corner here, and when it becomes black, I'm going to hold my mouse button down and drag down to 1.5. Okay, then I'm going to go to the next column on the bottom entry. You can't go to the top. The bottom entry is always, that's where you always drag. It's from the bottom entry in the row. So I'm clicking on that cell. I'm going to get the plus sign, the dark plus sign here. I'm going to pull down the column. And see, it looks like it's wrong right now, but I need to pull them all. So I'm going to go back to this column, the bottom row, which was the 2 here. I'm going to pull that column down also. Notice it's doing something now. And then the last one, and this will be the last time I have to do this. Pull it down. Okay? And then everything copied correctly. So what you're looking for, the answer you're looking for, using normal Euler's method, y of 1.5 is this 2.92781. This is the cell that I'm needing for my answer. I'll highlight that, this little highlighter button up here. Make it yellow. That's the answer that you guys are looking for. So whenever you submit your problem to me, this is the answer that I'm looking for. Okay, now this was done with normal Euler's method. So I'm going to now do this same problem. We'll compare our answers. Improved Euler's method should give us a more correct answer than this. This may either be an overestimate or an underestimate, but we'll see what we get when we do improved Euler's method. So I'm going to do a new spreadsheet. I'm going to click down here where it says sheet 1. I'm going to click this little plus sign and add a new sheet. Let me zoom in on this so you can see it well. Okay. This time, let's go back to before I start the spreadsheet, let's go back and talk about the formula for improved Euler's method. Okay, so here was our regular Euler's method formula. Improved is a little different. You got some of the same variables and some of the same information, but not all. So let's see. Improved Euler's method the formula is y sub n plus 1 is equal to y sub n original, we know what that is, plus the step size. Instead of times a sub n, remember we're going to go from two different lines and average them. So it's a sub n plus b sub n divided by 2. So that when we code Euler's method on our new Excel spreadsheet, we'll use this calculation instead of the old Euler's method. Now, to code a sub n, we're going to do it just like we did the old way. To code b sub n, though, if you think of that's a different setup. Your x is going to be your next x, not the one before, but the next one. So if you're talking about cell A2, the x you use would be A3, the next x value. And your y for b sub n is coded with the original Euler's method formula. So actually, I'll make a note. For b sub n, that's going to be a function of x of n plus 1, in other words, the next x, and then original Euler's method. Okay, for the y. So when you try to do f of x, y, this is the next x, and then Euler's method will have to be completely coded for the y variable. Hopefully that makes sense to you. So let's see. We'll set up our spreadsheet a little different this time, but a lot of the same stuff, and we're going to use the same problem. So the same starting point, initial value, the same step size, and we're trying to find y of 1.5. So that's not going to change. We're going to keep that the way it is. So let's go to Excel and see how it works. Now this time I'm going to label my columns a little different. I'm still going to have x sub n and y sub n. Then I'm going to do C and D column. I'm going to do C column. I'm going to do A sub n because we know that's part of what we have to code when we do improved Euler's method. And the next one I'm going to do B sub n. We'll code those separately. Okay. So on my first run through, I know my initial x value is 1, just like it was in the other program. I'm going to tab and we'll get you to the next cell. And then y sub n was 1 also. So the initial value was the 0.11. Okay, here we go. A sub n. That is original Euler's method. So I'm going to code this so it will calculate original Euler's method for me. So we know that y sub n, or say here, A sub n is the differential equation. That's what we use for the differential equation. Your differential equation is 2xy. So 2 times x times y. So this is equal to 2 times, x value was cell A2, times y, which was cell B2. So just like we did in the other one, it's pretty easy right there, okay? Good, and you're through with that. B sub n, however, is a little different. So we're going to still do 2xy, just like we did in the cell C2. 2xy, so this is equal to 2 times. Now, the x that we're going to use is the next x. So I need the x that we would see down here in cell A3. Of course, there's nothing there yet, but I'm going to go ahead and code it as A3. That's the next x, x sub n plus 1. So it's the next one that you would see. It's not this one again. It's the next x. Okay? So 2xy. There's 2. Here's x. And then times y. Now, here's where you got to be really careful. The y is coded as the original Euler's method variable. So what we're going to do, I'm going to use parentheses. Since I'm going to put an expression in here for y, it's going to be y sub n plus 1, that was cell B2, plus h, that was 0.1, times a sub n. And a sub n is actually cell C2. Okay, so let's look at this all before I move on to anything else. Make sure you understand. For B sub n, your equation for your DE is 2xy. The x is the next x that you would see. And the y is Euler's method, original Euler's method. Euler's method is y sub n plus 1 equals y sub n, that's that B2 right there, plus h times a sub n. So their step size is 0.1 times your a sub n, which was what we have here in cell C2. So 2xy, all y. Okay? All right, enter. So now I'm going to go down here. We're going to do just like we did on the other PowerPoint, and I'm going to add the step size in. So this is equal to the previous x, which was cell A2. And I'm going to add the step size to it. So we selected a 0.1 step size. So good there. Now I need to go here. Now this is the place where we're going to code the improved Euler's method formula. Now this is the last thing I have to enter. We're going to enter the improved Euler's formula. So here we go. Equals. Improved Euler's method said you're going to have y sub n. So that would be cell B2 plus the step size 0.1 times, okay, here's the part that's different. It's a sub n plus b sub n divided by 2. So I'm going to do this with parentheses. So open parentheses. I'm going to open parentheses again. And we'll say A2, which was cell C2. A sub n, which was cell C2, sorry. Plus b sub n, which is cell B2. So I got that sum. Then I'm going to divide by 2. That's got the average of the two. Close off parentheses. Okay, I think that's all of it. So let's go back and recap this. This is improved Euler's method. So it's y sub n, which was your first y value, plus the step size, 0.1, times the average of your a sub n and b sub n. So that was cell C2 plus D2 divided by 2. Got it all closed off on the parentheses and everything. So enter. And that is correct. So let's drag and see what we can get for y of 1.5. So I'm going to click on this cell. Again, I'm going to get the black parentheses, hold my mouse down and drag down to 1.5. Perfect. Bottom cell, always drag from the bottom cell from left to right. Okay, don't look like anything's happening yet, but it's fixing to. Okay, looking a little bit better, and do it one more. Last cell, bottom cell. Drag all the way down. And that is the correct answer there. So for using improved Euler's method, you got this value. I'll highlight that in yellow. Okay. Now, if you're going to submit your project to me, then it would be nice if you, when you get through, if you type your name somewhere in here. Plus, when you submit it in Blackboard, it'll be under your name. Or if you email it to me, make sure that I'll get it under your name. So make sure your name is somewhere for me to see it. So let's recap. The project that I gave for you should be in Blackboard. I believe it's already posted as your first quiz. So get the information. This is a problem that I did. This has got a whole different differential equation. It's got a whole different initial value. This is just an example for you to go by. So when you get your equation that I give you, make sure that you code things for that equation. So make sure you don't put 2xy in your problem. Your problem's not 2xy. and y of 1 equals 1. That's not your problem. You got a whole brand new problem to do. But use this as an example of how to set it up. So, I mean, this is not going to be a lot of partial credit. It's either going to be right or wrong. You've got 2 parts, so 50 points each. This is your first quiz. If you have questions, make sure that you contact me, and I'll see if I can't help. If you send it to me and see if I can find where your mistake is. But go ahead and get started on this, and I hope that you do well with it. I hope you think Microsoft Excel is a great tool. It really is.